Check. Hello people. Let me have a look at. All right. Good afternoon, people. We are here on day 31. Okay, it's been 31 days since we started this bridge course, and we are ending with calculus on the 31st day. That's pretty good. Takawa Tech. Good afternoon. How do you guys come up with these names? I will never understand. So today's agenda is are a couple of things. We will first do a problem on maxima minima, quickly summarizing what we learnt from the previous class. In case you guys have any doubts regarding this first problem that we discussed, you can go back and revisit the last lecture, and that was on maxima and minima. And let me tell you guys, maxima and minima is a very crucial concept. It's very crucial. So in case you have any doubts at any step, there were 1, 2, 3, 4, I guess, first differentiating the function, then finding the critical point, then checking whether that critical point is a maxima or minima using the second derivative test, and then calculating the maxima or minima. So there were 4 or 5 steps. There were 4 or 5 steps which were involved as far as this concept of maxima and minima is concerned. If you have any doubts at any of these steps, please go and revisit that step again. You cannot afford to have any backlogs or any doubts in any of these steps, because you are going to use differentiation to find maximas and minimas of functions throughout your 11th and 12th physics. Now you will keep doing it so many times that if you have any doubts, or if you're stuck at any of these steps, everything is going to fall apart in the future. Okay, so please go back and revise this. Hello Achyut, looks like you're here for the first time, and that too on day 31st of the bridge course. After I finish the class today, I will tell you how far we have come in the bridge course, what all topics we have finished, and what all we are left with. Okay. So question number 1 to you people. First problem. Please try this out. And this goes like this. Find the maximum or minimum values of y is equal to 9 minus x minus 3 whole square. So y is the output, as you guys have been seeing in all my lectures. This 9 minus x minus 3 whole square is my processing function, where x is my input and y is my output, right? So I want to find that x where I can possibly get a maximum output from the function or a minimum output. Remember, in the previous class I have told you it is possible for a function to not have either a maxima or a minima. It is possible for a function to have both maxima and minima. It is possible for a function to only have a maxima or only have a minima. It is also possible for a function to have more than one maxima. Any possibility, anything is possible, right? Anything is possible with a function. How do you test? You can't keep putting in random values of x, and you can't keep testing that for which x am I going to get maximum output or maximum input. You can't keep doing that. So what will you do? You have to use calculus, the steps that we discussed in the previous section, in the previous lecture, right? And guys, there are multiple ways in which you can do this problem. If you know how to draw the graph of 9 minus x minus 3 whole square, right now you would not know, but let's say you guys knew how to do this. So I know for a fact that here it will be 0, and then at x equal to 3 it will be maximum. Okay, here, right? Okay, x equal to 3, sorry, at x equal to 0, output will be 0. At x equal to 0, output will be 0. Yeah, at x equal to 3, your output will be 9. At x equal to 9, or 6, sorry, at x equal to 6, your output will be 0 again. So graph will look something like this. If you guys know why is there so less watching, is it a YouTube glitch? Maybe it is possible, or maybe some people are having their coaching classes also. That is why I put up a recording of these lectures, so that if somebody has a coaching class to attend and they have a compulsory attendance, to keep up with, then they can watch these recorded lectures. But I strongly have confidence in most cases these classes are going to be much more useful than your coaching classes for sure, because at least here you will understand stuff. Okay, so if you know how to draw the graph for this function, you can solve this question without calculus also. You can do that. But right now you guys don't know how to draw graphs, right? Because most of you have finished your 10th. If you were in your 11th or 12th, if you had studied graphs in mathematics, and if you had studied how to draw graphs, how to use calculus to draw graphs and all those things, then it would have been fine. Oh, thank you, Achyut. Thanks for your compliment. Then it would have been fine. You wouldn't have had the need to differentiate and do all those things. You could just solve it by drawing the graph. But right now, you are not in that position. You have to reach that position in some time. It will take you a few months to be able to draw graphs of functions, right? So, guys, all these blocks that I've been talking about, these functions, each of these functions have a graph. They can be plotted on an xy axis. Now, to draw something like y is equals to mx plus c, let's say. So if you have mx plus c as your function, it is simply a straight line with slope tan theta equal to m and y-intercept of m, right? It's very simple, a straight line. If you have something like y is equal to, what else do you guys know? What function would you possibly know? If you know y is equal to sine x, let's say, then graph for sine x is like this, right? This is y, this is x. Like that, every function has a graph. You give the input to it, you get the corresponding output, then make the xy pair. Like that, give x2 as input, get its corresponding output, make the x2 y2 pair. And all of these are points, okay? They are all having x and y coordinates. So plot these points on the graph. You will see how a function looks like on a graph. Some functions are simple to draw because you have been seeing them since class 9th, class 10th, class 11th, 12th, you will see them so many times that it'll become very easy for you to draw their graph. But there are some functions. Drawing their graphs is not easy, guys. Something like sine of log x, very difficult. It is not sine x into log x, it is sine of log x, composite function. How do you draw this? To draw graphs of complicated functions like these, you have calculus. But in physics, we don't really require that. If you look at applications of calculus in mathematics, there are many. In physics, we only care about some specific applications of calculus, and maxima and minima is one of them. Okay, so because I don't know how to draw graphs properly, I will have to solve this problem using calculus. So what is the step 1? What is the first step involved in calculating maxima and minima? Maxima or minima. I don't know whether this function has a maxima or a minima, or whether it even has one of these, right? So for that, step number 1 is I will differentiate this function. What is my f of x? 9 minus x minus 3 whole square, correct? So I will differentiate this fellow, and what will I get? 9, if you differentiate, it will become 0, then you have a minus sign, fine. And if you differentiate x minus 3 whole square, you will get 2 into x minus 3 into 1. Please guys, I have used chain rule here. I have used chain rule to differentiate this function. If you are not clear with what chain rule is, please visit one of the previous lectures, or if you have any doubts, please put it in the chat box. Okay, so f dash x is equals to minus 2x plus 6. This is the first derivative function. Next step is to find the critical points. How will you find the critical points? You will equate this f dash x. You will equate this f dash x to 0, and from this you will get x as 3, which means x equal to 3 is a critical point. And it is a critical point for which function? Is it a critical point for f dash x, or is it a critical point for f of x? I had asked this in the previous class also. It is a critical point for f of x, guys. Which means this function 9 minus x minus 3, if I give x equal to 3 as input, something will happen. Either I will get a maximum output that's possible from this function, or I will get a minimum output, or I will get a sharp point. Like I don't mean to say you will get a sharp point. I mean to say this x equal to 3 is a sharp point. I should say that, but you don't care about that sharp point right now. Please forget about it. You will see that in mathematics. So for now, because you are studying physics and you are in the beginning only two things will happen for you right now. When you give x equal to 3 as input, either you'll get a maxima or a minima. Now how do you test? That is step number 3. You will have to double differentiate the function f double dash x. What is f double dash x? Which means you will have to differentiate this fellow. F dash x has to be differentiated one more time, and you will get minus 2. So minus 2 is a constant function, and now I will have to put my critical point as input to this function, and if my output is more than 0, I am going to get a minima. If it's less than 0, I am going to get a maxima. So put x equal to 3 into this. Because it's a constant function, minus 2, your output is going to be minus 2 only. Whether you put x equal to 1, x equal to 2, x equal to 3, doesn't matter. Your output is going to be minus 2 only, because it's a constant function. It does not depend on the input. Yes. I hope you guys understood what I meant when I say constant function. So since minus 2 is less than 0, the output is less than 0, this x equal to 3 is going to give a maxima, not minima, because your output of the critical point from the double derivative function is a negative quantity. That's why it's going to give a maxima. And you guys, if you are not clear with this rule, just check the previous lecture. Everything will be clear. Okay. So I have found that this fellow 9 minus x minus 3 whole square, if I give x equal to 3 as input, I am going to get the maximum output possible. For no other input, for no other input I can get an output that is more than what I get when I put x equal to 3 as input. That is what I mean. Correct? Now step 4 is to calculate it. How do you calculate the, like you have, so remember guys, at this point of time you don't know what that maximum output is. You only know that you will get that maximum output when you give x equal to 3 as input. But how do you calculate what that maximum output is? For that, just put x equal to 3 in this. 9 minus 3 minus 3 whole square, which is 9. So this maximum output that I'm talking about is 9, which means in this function 9 minus x minus 3 whole square, when I give x equal to 3, I get 9 as my output, and for no other input I can get an output more than 9. You can't give an x such that the output will be more than 9. Not possible. But you get 9 only when x is 3. That is another point that you have to keep in mind. So this was the concept of critical point, and this was the concept of finding maximas and minimas. If any doubts, previous lecture, please feel free to refer to it. And I believe if you haven't really been following stuff, that's probably because you haven't been attending live classes regularly. Anyways, there is no point requesting people to come live again and again now. That is because today is our last day with calculus anyways. So guys, I taught you differentiation and integration basics. I told you, I basically explained you the concept behind differentiation and integration. Why do we need integration? Why do we need differentiation? How do we go about it? We saw all these things. We discussed some formulae, 10 formulae for differentiation and 10 for integration. For differentiation, we also saw 4 laws. For integration, we still haven't seen any laws. But guys, I would like to tell you, differentiation does not really have laws. Differentiation has 4 laws. These 4 laws, when it comes to differentiation, these 4 laws plus these 10 formulae, if you combine these two wisely, these two sets of information that I have given you from this class wisely, you can differentiate any function that's given to you, no matter how ugly it looks, whether it's sine of, log of, mod of, cosecant x square, doesn't matter. No matter how ugly it looks, no matter how many compositions exist within the given function, you can differentiate it just using these 4 laws and 10 formulae. You don't need any other theory. You don't need any other framework to differentiate. But integration, my dear people, is not that easy. Integration is not that easy. Integration has these 10 formulae, and it has roughly, in your syllabus, it has about 12 to 13 models. In fact, not even 12 to 13, I should say 15 to 20 models. There are hardly any laws in integration that you will need to study. You will have to study, instead of those 4 laws that we studied in differentiation, we have to study these 15 to 20 models, which you will study when you study this chapter. You will study these 15 to 20 models when you study indefinite integration in mathematics. We will not cover these 15 to 20 models in physics because it's too exhausting, and frankly speaking, it's not even a bit of these models is required, but we still can't do it. We will have to rely on these basic 10 formulae only for now. I hope you guys have memorized these 10 formulae that I had given you, right? because we will just be using these. But remember, in physics, when you study chapters like rotation, when you study chapters like center of mass, chapters like these, here you will have some heavy integration. You will feel that sometimes these 10 formulae will not be enough. You will need more information, more models to integrate, because let me tell you what makes differentiation easier from integration. So I am telling you that differentiation is easy, and I'm telling you integration, on the other hand, is not easy. And why am I saying this? Why am I saying this? Because differentiation just requires those 10 formulae, those 4 laws, and with this you can differentiate any function that I give you, no matter how ugly it looks. What do I mean by ugly functions? Functions which are composite of each other, like inside one function you have one more function, inside that you have one more function, inside that you have one more function, like those block diagrams. If you remember, if I make many of those block diagrams, differentiation is still easy on that, but integrating that function is not easy. And why is that? Because integration, first you need to know these 10 formulae. You need to know these 10 formulae. Then you need to know these 15 to 20 models, not 4 laws, 15 to 20 models. And even this will not be sufficient sometimes. Sometimes you might get a function which is not even in those 10 formulae or not even in those 15 to 20 models. Most likely it will not happen, because you will get functions which are a part of your syllabus, and your syllabus means these 15 to 20 models. So that's why it's not as direct as differentiation. And let me tell you which rule is responsible for this difference. Which rule makes differentiation easy but integration difficult? I'm not saying integration is difficult, I'm saying it's not easy. There is a difference between them. There is a difference between these two statements, guys. Okay? So it is this rule, chain rule. Correct? We studied chain rule as one of the laws of differentiation. Correct? Like if you have many functions, f1, f2, so on, fnx, like composite, n functions are composite of each other. We saw that we can differentiate this also using chain rule. But we don't have a chain rule in integration. Integration does not have chain rule. And this is sad. This is sad, people, because it is the absence of this chain rule because of which we have to study these 15-20 models separately. And even then we might still get some functions which do not lie in this 10 formulae plus 15-20 models bracket. You might get something which will require some other knowledge to integrate. You will most likely not get that in your syllabus, but it is still possible. And all that is because integration does not have chain rule. Like you can differentiate this function using the chain rule formula that I gave you in the previous class. But if I ask you to integrate this with respect to x, you will go mad. You can't integrate it using chain rule. Like you can't say I will integrate f1 first, keep all the inputs same, then multiplied by integrate f2 second, keep all the inputs same. That is wrong. There is no chain rule which exists for integration. And that's why when you study integration as a part of mathematics, only then you will get some confidence. Otherwise, even in physics, when you come across integration, if the function gets a little complex, you will struggle, you will get scared, but please do not panic. Wait for integration to come in mathematics. Once you study that as a part of mathematics syllabus, and to be more fair, once you study integration as a part of these 15-20 models, then it will start getting a little more easy. Okay. Anyways, we will just do some problems based on the formulae that I gave you. Question number 1, integral 5x square plus 3x minus 2 dx. And whatever we do now, that should be sufficient for the first few months of your physics, until you don't, only when you come across this chapter, rotation, center of mass, when these chapters come, then you will study a little, then you will struggle a little with integration. But before that, whatever you get, you will be able to do. It will be simple. It will not be complicated. When these two chapters come, then you will start getting a little, nervous. So how do you integrate this? What all formulas do we need? We just need this one formula. X power n plus 1 by n plus 1 plus c. This is, I think, the first or the second formula in the list of the 10 formulae that I gave you. And with this, you can solve this problem. You don't need anything else. First of all, whenever you have a plus or a minus, just like differentiation, you can split it. You can write it like this: 5x square dx plus 3x dx minus 2 dx. You can do this. Like, remember, if we had something like, if a function capital F was nothing but small f plus g plus h, then when you differentiate f, you can differentiate small x separately, g separately, h separately, and you can add them or subtract them if they are subtracted in the parent function, right? You can do that for differentiation. You can do that for integration also. If you have a plus or minus between functions, you can split the integral into 3 parts. Here 5x square is one function, 3x is another function, 2 is another function. You can split these into 3 integrals and now integrate each of these separately. Constants can be pulled out of the integral. This I have told you before. If you have integral k f of x dx, where this k is independent of x, which means if I keep changing the value of x, k has got to do nothing with it. K does not depend on x. Then I can pull k out of the integral and I can say k into integral f of x dx. I can say this, which is why I can pull 5 out, here I can pull 3 out, and here I can pull 2 out, because these are constants. They do not depend on x. And that's all. How do you integrate this? X cubed by 3, because you will use this formula, n plus 1 plus c, right? So I will put a plus c in the last. So put n equal to 2 in this, guys. Then it will become 2 plus 1 by 2 plus 1, which is x cubed by 3. That is what I did. Okay. Plus c, let's say c1 constant, plus 3 into, now put n equal to 1 in this. To solve this integral, you will get x square by 2. Then put n equal to 0 in this to solve this integral. Integral dx is just x, right? Because if you put n equal to 0, it will become integral dx is equals to x power 0 plus 1 by 0 plus 1 plus c. And that's x, correct? I know, guys, some of you are really getting a little nervous with integrals and all. Please keep patience. Please have faith. Keep your doubts ready and ask your doubts. By the way, there is another constant c2, another constant c3, it will come. I can combine these 3 constants to write a grand constant, like something like this, c, where this c is nothing but c1 plus c2 plus c3. You can combine constants and write a constant, right? Remember, if you go back to that list of formulae that I gave you for integration, every formula in that list has a constant, has a plus c. Integral x power n dx was nothing but x plus 1 by x power n plus 1 by n plus 1 plus c. There was a plus c in every formula of that list that I had given you. Please check that. Please verify that. That's why I am putting a constant in my final answer. If you miss this constant in your final answer, it's going to go wrong. Okay. Right, let's move on to the next problem for today. Integral for sine x minus 2 by x dx. If you want, you can sit with the sheet and do the problems with me, if you wish. How do you do this? Split this into two parts. 4 sine x dx is one part. There is a minus sign, so put that. And 2 by x dx is another part. Once again, I will pull the constants. I will pull those terms which do not depend on x out of the integral. Because I am integrating with respect to x, I can pull all these terms which do not depend on x out of the integral. Okay, so I've done that. 4 sine x dx minus pull 2 out 1 by x dx. Now what is the formula for sine x, people? How to integrate this function sine x? Does anybody remember? Yes, it's minus cos x. Okay, obviously a plus c will come, plus c1. What is the formula for 1 by x dx? Does anybody remember it from the list? It's log x. It's not log x actually, it is ln x. I can say ln x, or I can also say log x base e. Okay, natural logarithm. So let me say, instead of log x base e, let me say ln x plus c2. So you have minus 4 cos x minus 2 ln x plus c1 and c2 can be combined to write a finally write a grand constant c. This is your final answer. There is nothing much to understand here, people. It is just practice, practice and repeated practice over these models, over these problems, over that sheet. And in fact, there will soon come a time where that sheet will not be sufficient. You will have to also learn those 15 to 20 models of integration which I was talking about. Okay. Problem number 3. As long as you are able to follow these problems that we are discussing in the class, it is sufficient. You are mostly going to revolve around this only in the for the next few months of your 11th class syllabus. Okay. This is how do you integrate this function 4x plus 5. So out of these 15 to 20 models, there is one model called as substitution. We are going to use one of those models for this problem, because the problem here is, if it was 1 by x dx, you would know that it is ln x plus c, ln x plus c, the answer. But you don't have 1 by x dx, you have 1 by 4x plus 5. Like you have a function of x. So this is actually one of these models of this function comes as one of these 15 to 20 models. So right now you are nowhere close to understanding that. So I will just show you a substitution trick to solve a problem like this whenever you come across. Put 4x plus 5 as capital X. And now differentiate on both sides. If you differentiate on both sides, this will become 4 into dx, plus if you differentiate 5 with respect to x, it will be 0, and this will be d capital X. Or rather, let me show you like this. So I am saying that this capital X is 4x plus 5. Differentiate this capital X with respect to x. Differentiate this capital X with respect to small x. What will you get? 4. Correct? When you differentiate this function with respect to x, you will get 4. So d capital X is nothing but 4d small x. So now I will substitute this and this in my integral. How will I and how will my integral look like then? Let's see. So then d small x is going to become capital D capital X by 4. because d small x is d capital X by 4 according to this equation. So I did that, and 4 small x plus 5 is nothing but capital X. All right, this is nothing but, now I can pull 1 by 4 out. 1 by 4 can be pulled out because it does not depend on capital X, as I've been saying in the previous problems also. I can pull those terms out of the integral which do not depend on the variable with respect to which you are integrating the function. Here you are integrating the function with respect to capital X. 1 by 4 does not depend on it, so pull it out. Then you have d capital X by capital X. What is this? 1 by 4 ln of capital X. Ln of capital X, guys, not ln of small x. Now I will have to substitute this capital X back with this. Okay. Since I'm not getting any doubts in the chat box, I'm assuming people are understanding this. So how far have we come? We know that capital X is 4 small x plus 5, and we got our final answer to be 1 by 4 ln of capital X, which is nothing but 1 by 4 ln of 4x plus 5, 4 small x plus 5. Okay. I substituted capital X as 4x plus 5 again from where I had started. So did you see? Substitution helped us here. Substitution, if you want to know how I did what I did, you will probably not understand everything properly right now. But substitution is one of the models, one of these 15 to 20 models which you are going to study in the future. Okay. And if you have any doubts related to what I just did, chat box, feel free, which is why I ask you guys to come live. Let me discuss one more problem before I close this session. Okay. And this should be sufficient. This much knowledge on integration and differentiation should be sufficient for you to deal with the upcoming topics in physics. What do you do about this fellow? 6x plus 2 whole cube dx. There are multiple ways in which you can integrate this function. First of all, you can't directly use a formula from that list. Why? Because that list has x power n dx as x power n plus 1 by n plus 1 plus c. If you had integral x cube dx, then you could have used this x power 4 by 4 plus c. But here you have 6x plus 2 whole cube. So instead of x cube, you have x whose coefficient is 6, and then it's added to 2 and then raised to the power. The whole thing is raised to the power 3. There is no direct formula for this. Even in fact in the previous problem also, that was the problem that we had. We did not have a direct formula with which we could integrate that function. So how will we integrate this function? What will we do about this? Step number 1 is either you can use a plus b whole cube formula. I hope you guys know this. A cube plus b cube plus 3a square b plus 3ab square. Either you can do that and split this as 6x cube, which is 216x cube plus 8 plus 3 into 2 6 6 36 3a square b. So 3 into 36 into, okay, so 216x square, or you could have 3 into a, which is 18 into 4, which is 72x. So either you could integrate this. So what I did, I just split the bracket as a plus b whole cube, and then you can integrate each of these parts separately. You can pull the constants out. 216x cube dx plus 8 dx plus integral 216x square dx plus integral 72x dx. Pull the constants out if you want. You will have to actually. 8 dx plus 216x square dx plus 72x dx. Now if you see, each of these integrals, x cube dx, dx, x square dx, x dx, all of them are of the form x power n dx. And you know the formula for this. So I have reduced my function from this form to this form by just splitting it on a plus b whole cube formula. Instead of this, I could also do one more thing. From here, I believe you can integrate, just put n equal to 3, n equal to 2, n equal to 1, and n equal to 0. And you will get all these 4 terms. In this one formula, you will just have to put n equal to 0, 1, 2, 3, and you will get all these 4 terms. Okay. But there is one more way you can integrate this. And that's a lot more simpler. Put capital X equal to 6 small x plus 2. Substitution. Again, one of those 15 to 20 models. You will not get a hang of this until you practice. Integration is not going to come from a bridge course or from a couple of classes. There are coaching institutes which teach integration for 3-4 months for people to master, and it's taught every day for like 2 hours. First it's taught for like 1.5 to 2 hours, and then students practice it for so many hours. Only after that they get this, right? Only after that they start getting a hang on the models and all these things. So I'm just showing you how integration looks like. I'm in no way teaching you how to integrate, because nobody can teach you that. They can just show you. You will have to practice it again and again so that your hands get used to integrating functions. Unlike physics, wherein I can explain you a lot of concepts, here there are very limited concepts, but there is lots of practice, right? Whatever concept had to be explained, I've already explained that in the beginning itself. Okay. So now differentiate capital X with respect to small x. You will get a 6 when you differentiate this function. So d capital X by 6 is d small x. So this and this, we will use these two, 1 and 2, to reform this integral. So 6x plus 2 is capital X whole cube, and d small x is d capital X by 6. Once again, I can pull 1 by 6 out of the integral because it's a constant with respect to capital X. And then I'll get capital X cube d capital X, which is nothing but x power 4 by 4 plus c. Already discussed this formula with you. As I explain you this problem, I can figure out there are many more nuances to this, which right now you will not be able to see. But give yourself time, guys. Integration is one of the most difficult topics in mathematics. You are looking at one of the most difficult topics in mathematics, or for that matter, entire JEE syllabus. Which is why please do not run out of patience with integration. You will have to, if differentiation is 4, integration is 20 in terms of difficulty level. So please have patience. Today is my last class with integration, which is why I can't give you more lecture about how to keep patience with integration in the future. That's why I'm putting enough emphasis today. Now, will you leave your answer like this? No, right? Because you brought this capital X. You have to get rid of this capital X with your substitution again. So go back. Answer is 1 by 6 capital X power, which is 6x plus 2. Capital X is 6x plus 2 power 4 divided by 4 plus c. Don't forget this plus c. Very crucial in integration. Okay. 6 into 4 is actually 24. So 6x plus 2 whole power 4 by 24 plus c. This is the answer to the question. Okay, guys. So with this, we are done with calculus. Whatever basics we had to cover, we have done it. And we have come a long way in the bridge course. We started with units. Then we did dimensions. In fact, it was a whole different chapter wherein we saw a lot of problems. We did error analysis. We discussed how errors are calculated, how are they caused, how what are the different types of errors, what are combination of errors, how are errors represented in laboratories, what is their physical significance. So much we saw about it, right? Moving forward from error analysis, we moved to instruments, and we saw vernier calipers, micrometer, screw gauge, their concept, their application, right? Then we moved to vectors. We spent about a week or 10 days on understanding the concepts of vectors, its operations, algebraic operations, how it's represented, where it's used in physics, all the things. Then we discussed calculus, wherein we saw the basic concepts of differentiation, integration, all the problems. It took us exactly 31 days to finish all of this, right? Wherein I told you these two themselves are about 70 to 80% of the syllabus, and this is like some 10 to 15%. So congratulations, we are done with more than 90% of the bridge course. We are only left with one chapter, which is Intro to 1D Kinematics, which we will start from Monday. And this is only about 10% of the bridge course. We will take another 4 or 5 days max to cover this, and after that we will only have 4 or 5 days left. By June 30th we will close the bridge course, right? We will discuss some random mathematics topics after we end this, but I'm sure for all of you who have been following me regularly for the last 31 days, you guys are on a different level altogether when it comes to conceptual understanding, way more than your peers. I can take a bet on that. All that you guys have to get used to now is problem solving with more and more questions. I hope you will not struggle with your 11th syllabus, right? And that's all actually for today. I'll see you guys on Monday. We will start with this new chapter called as Intro to 1D Kinematics. Now you will start getting proper physics fields. Actually, until now, whatever we were discussing, at the end of the day, all these topics were mathematics topics. They were hardly physics topics. This bridge course, if you notice, was all about mathematics and physics. In fact, I could rename the entire bridge course to mathematics and physics, right? We hardly saw diagrams, calculations, physics concepts, but we will start seeing that from this chapter. And in fact, from now on, you will only see that. But I hope these 31 days were, power packed for you, and you indeed learned a lot of concepts, and I hope that will be useful for you. In fact, I'm sure that will be useful for you. You guys are on a different level altogether when it comes to conceptual understanding, provided you have been following me properly for the last 1 month, right? And for those of you who haven't, all these lectures are there from day 1 to day 31. All the lectures are there on this YouTube channel. You can sit, watch it, get your concepts right if you wish. And with this, we will end this week. We will end this 31 days stunt, actually, the whole month. And I'll see you guys on Monday. Take care, stay safe, and bye-bye. See you guys live. Please come live for the last, this is more like the final week now. Next week is almost the final week for us. After that, we'll have like 2-3 days left in the week after that. Okay, I'll close the session now. Thank you for joining, guys. Bye-bye. Stay safe.